This meeting is being recorded.
Hello and good day. My name is KenMcClenithan, and I've been in IT for about 35 years, mostly as project manager and now Scrum Master Agile Coach. I took this course at Duke University to better understand what my team was running up against using machine learning and AI. So in this particular class, we were given a project in which we were given some data to try to extrapolate which of the features being ambient temperature and other features, I'll explain to those later, and try to find out which one was the best, was correlated to the best of those values. I don't like to admit it, but the math was far beyond me. It's been a long time since I've had to work with any kind of math and formulas the way that we were asked to do in this course. And I admit that I did not finish the entire presentation as far as the mathematics. I did get as far as I could. Moving on to the next slide. So our problem statement, we were to predict electrical energy output from a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. We were given a set of 9,568 hourly average ambient environmental readings from sensors at the power plant, which we'll use in our model. I'm not going to drain the slide on this one to show you the abbreviations. So in looking at this data, I did decide that I was going to use a parametric linear regression model to identify the relationships to the features from the target. I did notice that there were one other feature that was a very close match, but the one, as you'll see in the slides, was very, very closely matched, or better matched than all the rest. So out of the 9,500 records we were given, 20% were used in the initial validation, 20% in testing, and leaving the 60% in for the final implementation. Again, the parametric models are used when the relationship between the response and exploratory variables is known. So we had that information. So we didn't have to go non-parametric. So here are my graphs. As you see, the ambient temperature versus output powers is directly correlated. And also I noticed that the output power also is almost completely correlational with the output of the power. But we noticed that in both cases, as the ambient temperature increases, the power output declines, and the same with the vacuum. As vacuum increased, the power output declined. The other two features, it was all over the board, so I eliminated those visually. And again, this is the next part is where we get into the math, and again, I admit that I didn't use the math the way I should. Again, it was far beyond me, but here is some of the information, the rest of the information, and you can see from my presentation, I did not go any further. So after reviewing the scatter plots of the data, a number of the features, there were two of them, were very, very closely matched. And I feel that that would be the way to move forward with those two particular features. I did not use the lasso regression, nor did I use a ridge regression. But again, if we ever need to, we could go back to those. And once again, I apologize. There is no math in this particular presentation, and I will close my project for this class. Thank you for the review.